Hi, my name is Hsiang. This has been a lot of fun hearing from everyone here and getting to meet everyone over lunch. I'm at Berkeley where I run the Global Policy Lab, and we think about sort of these really large-scale questions about how we manage resources on a planetary scale. Are we allocating these in a way that sort of maximizes the potential and the well-being of individuals around the planet? We live in a world where we're sort of full of technological promise and we're achieving things that we've never seen on this planet, buildings that are reaching almost a kilometer in vertical height. We're also landing rockets, sort of Iron Man style, out on autonomous rafts in the middle of the ocean. These are incredible feats of technology. At the same time, millions of children grow up around the world with their bellies distended because they're full of worms, because individuals have not been provided sufficient sanitary conditions. And to escape those types of conditions, people around the world are trying to develop as quickly as possible, accumulating wealth. But this puts a huge amount of strain on the atmosphere because we have people around the world sort of consuming energy, and they're doing it to better themselves. So that's an important activity, but we can make investments today that can maybe change the future trajectory of the planet. And so the question that's sort of my job is to think about I won't use a pointer, is to think about sort of what the world on the right-hand side of that screen, what those states of the world look like, so we can think about what their value is to society, and then balance that against the types of investments that we would make today to achieve any of those states of the world. Now, it's not just an exercise of throwing all of our money that we possibly can at climate change, because as you can see, there's people around the world today who have real opportunity costs of their resources. They should be investing in education for their children. I don't want people to close the fire department to fight climate change. So there's sort of a fundamental scientific question at the core of this policy challenge, which is trying to determine sort of whether or not the climate has a big impact on human societies, in which case we might want to invest very heavily in maintaining a certain climatic condition, or maybe the climate actually just has very little effect. Maybe we've sort of gotten to a point where we can just use technologies to sort of overcome the challenges that the environment poses for us. And this is a famous question. Montesquieu, Aristotle have all written about these ideas, asking, to what extent does the environment determine, the conditions of society and people's well-being? So this is not, people have been thinking about this for a long time because it's a hard problem. You essentially have a climate system, which we've seen is this very high-dimensional system, and we have a very high-dimensional economic and social system, and then they touch each other in, that's a bad analogy, they connect with one another in many different ways, and each one of them is complex and has a large number of confounders. And so what you need to do is think about trying to extract some sort of signal to understand how the environment is affecting people. So what we'd like to do is, the experiment we've now talked about many times, but in this case we'd like to have two different worlds, and we'd like to heat one up and then see what the people on the warm world look like relative to the normal world, right? That would be fantastic if the IRB would approve it. They don't, so instead we're stuck with sort of quasi-experimental approaches. Now, what people did historically, if you look at what Aristotle did, or others have talked about, they kind of were looking at like Norway and Nigeria, and they were saying, look, Norway's cooler, it's richer, more peaceful. Nigeria is hot and humid, and so obviously being hot and humid is bad for all these reasons. That's a confounded experiment. So what we do now is we think about whether or not we look at populations over time, and we look at as they're exposed to one climatic condition versus another. And in doing so, we're at least ensured that sort of the unit of observation that we're looking at has sort of a constant historical heritage, constant geography. That population is the same group of people traveling through time. And so we think that's a more credible experiment. In reality, we're not just looking at sort of two states of the world. We're actually looking at a whole continuum of states. And so what we do is we apply sort of econometric techniques, which are really good for extracting signals out of these high-dimensional systems, and we try to back out from them what the response in the social system is as the environmental system is varying. So on the top panel, panel A, you can see sort of two climate distributions. We talk about the climate as this probabilistic distribution, but we don't actually experience that distribution. We experience a sequence of events that are drawn from those distributions. So in panel B, you see times going down. And the empirical challenge is to back out something that looks like this response function here in the lower left, panel C, where we see that some change in the climatic condition leads to some different social outcome. Okay? And so this is an inferential problem where we're basically trying to deconvolve the relationship in the data. But then once we know what that relationship looks like, we can build simulations. We can take like sort of NOAA's climate models, and we can look at how the distribution in social outcomes over on the right might evolve as the climate evolves. Okay? So this is the general approach that we take to this problem. And now what I'm going to do is walk you through sort of 3 examples of ways that we're learning about our relationship to the climate and how that affects what we think about its valuation. So after every tropical cyclone that's a large destructive event, people kind of ask these types of questions. How does a population recover? How do they rebuild? This is a picture of Typhoon Haiyan that was devastating for the Philippines. And so to do that, we build a model of what the physical structure of the cyclones are. So this is sort of a piece of the model where we're looking at the wind field, and we move it through space, and we allow it to evolve. We simulate what was going on in the storm in the historical record. So this is a sort of flip book looking at Super Typhoon Joan that passed over the Philippines back in 1970. And that lets us reconstruct what individuals on the ground might have been experiencing during that event. We then take that and we reconstruct it for all the storms that are recorded around the planet. And so here's just a snapshot of 2008. There's roughly 100 storms per year on planet Earth. And then we reconstruct that for all years in the incomplete historical record to sort of rebuild what all people on Earth's exposure to all recorded hurricanes since 1950 have been. And then we use that to learn about how they're responding to these events. So in one particular study, we took really detailed data in the Philippines, where we take like a few 100,000 household surveys, and we ask questions like, what is the probability that a household is missing strong walls? Okay, so there's lots of things that would predict households should have strong walls, and what we see is that the year before, if they were exposed to a more intense cyclone event, there's a higher probability they're missing their walls, presumably because they were knocked down in the prior year's event. Now you can actually repeat that exercise for a variety of other durable assets, and you see the same pattern. So people are losing their refrigerators, they're losing power, they're losing their televisions when strong cyclones are passing through. One interesting thing that actually I think is intuitive is that they're not losing their cars. But you actually have 6 hours of advance notice before a storm hits your community, sometimes longer, and people are driving their cars up a hill to where they're protected. It's much harder to drive your refrigerator up to the top of the hill to protect it. And so we see those things are getting destroyed. And the loss of these assets leads to local economic depressions, where people are earning less money, and the households have to cope with reduced income by changing their spending patterns. And so on the right, what you see is a change, a reallocation in how households use their money, just in this case, between different types of food products. And you see that in the years after a strong storm on the right, households are spending up to 30% less on nutritious foods like meat and eggs and fruit, and they're shifting in relative terms towards things that are less nutritious, things like cereals. Now this kind of disinvestment behavior has real health consequences for these households. So we're actually able to reconstruct the record of births and families across the Philippines, and what we see is that in the 2 years after a typhoon, there's a huge rise in infant mortality among female infants. And interesting, I'm sorry about the flickering, I don't know what it is. Is there any way we can run it off the other one? Okay, so what we see is for the 12 months after, for the 24 months after these typhoons, these female infants are being born and they have an elevated risk of mortality. And we think a lot of the channel through which that's happening is this economic channel, because about half of the infants that are dying after the storm were not even conceived at the time that the storm struck their community. So they couldn't even been exposed in utero to these events. And we also see that female infants born into families that have older siblings are actually twice at risk of dying after a storm, presumably because they're competing for resources within a shrinking pot of resources within the household. And we see that if that older sibling is a male rather than a female, their risk of mortality doubles again. So the most difficult thing is to be sort of bargaining for household resources in the wake of a storm if you're an infant girl when you have an older brother to compete with. So what's interesting is when we compare our calculations to sort of the numbers that you would see in the newspaper about what are the sort of economic damages or the mortality in different types of storms, we compare sort of apples to apples during the period of record. The numbers you would see in the newspaper are the two bars on the left. The implied economic and human toll of these storms over this record are the bars on the right. And so what this is telling us is that a lot of the costs of these events are going unrecorded because they're much harder to detect. They're not as conspicuous. They're not just buildings falling down. But once you apply data to the problem, you see that the losses are roughly 15 times larger than what we were predicting. Now that general pattern is something that we're observing at the very micro scale at these household levels. But you can think about sort of what's happening to the overall larger economy. And so economists, macroeconomists for a long time have written down many theories about what might happen to a country when it gets hit by a disaster. You know, there's these various theories. Here's a schematic with GDP on the y-axis and time on the x-axis. And you see these countries are growing, they get hit by a storm. So some folks have said, well, there's some creative destruction thing that happens where people are perturbed from their habits and they get good ideas and they become innovative. In other cases, if you're like the mayor of a city, you might say we're going to build back better. We're going to suffer for a little while, but then we're going to pedal really fast and our economy is going to recover. We're actually going to come back stronger than we were before the storm. And then, sort of everyone's favorite one is this idea that we recover relative to the trend at least, and we end up at least as good as we were before. And then there's this kind of depressing looking theory of no recovery where you get hit by the storm. You eventually continue to grow, but you're permanently on a lower trajectory than you were initially. So what we can do is we can take our reconstruction of these 6,000 storms around the planet and apply them to macroeconomic data. And what we find is that the no recovery hypothesis looks as though it's true, at least to the horizon of 20 years. And so, a storm strikes your country, and we see that for the 15 years after the storm, your economic growth rate has declined, and 20 years after the storm, we can actually still detect sort of the fingerprint of that event on your economy. This is an interesting fact. This is really interesting to us because it seems like so generalizable. You can actually cut the data many different ways. You can go to rich countries, poor countries, small countries, big countries. You can go to East Asia or North America, and you can actually recover the same result. It looks almost like sort of a rule about how human societies are interfacing with their environment. And what we think is sort of important about it is that this is an impact that has sort of not been talked about in sort of the economics literature. But this is a graph the economists put together, sort of comparing our results to other types of large-scale macroeconomic events that we spend a lot of time talking about, things like financial crises or civil wars. And the magnitude of cyclone impacts are definitely in the same scale. And so we think that these are important events that need to be sort of considered. And when the title of the slide there is what happens. We do a calculation where we turn up the volume on hurricanes following a portfolio of simulations, and we see that the losses are roughly $10 trillion that we should be willing to spend today to avoid them in the future. Okay? So that's like a loss that's not been accounted for in previous economic models. And one way to think about hurricanes, I think it's sort of simple, but what we sort of think is going on in the simplest way is it's kind of like what happens when you're at the beach, right? If you sprinkle kids around on a beach and you make them all build sandcastles and you let them do that for a while, the sandcastles will grow, but the guys who are near the waves will occasionally get hit by a wave, they'll get washed out. And so that will sort of shrink a little bit, and then over time the kids will build it up again. But at the end of the day, if you look at the distribution of the size of the different sandcastles, some locations will have more than others. And when we actually take those microeconomic household level results and ask what would they predict if we had sort of this kind of sandcastle depreciation effect happening across regions of the world, we actually see that the long-run growth rates of countries across Asia sort of reflect the patterns. Use this guy. Reflect the patterns that we see in terms of long-term growth. So we're starting to get closer to this sort of state where we actually can attribute large-scale cross-sectional differences in how societies are growing to large-scale patterns in the environment where they're trying to develop. So shifting gears a little bit, we can ask the kinds of questions of, we have these large-scale climatic events. They have large economic impacts. You might imagine that this can be destabilizing. And so in some of our, there's many climatic studies like what Valerie was showing, and I think that's Valerie's paper on the lower right. Here was a synthesis that we put together trying to show sort of many different studies all on the same axes. We see that throughout history, the orange bars are periods of major instability. So for example, the collapse of the Maya was sort of in sync with large-scale droughts. Those happen to be the same droughts that occurred on the other side of the Pacific Ocean that brought down the Tang Dynasty. We see a variety of events throughout Europe, and so you can ask whether or not sort of large-scale destabilization is possible today. And there's some different theories about what might be going on. So there's some really interesting psychology studies. I don't know what their p-values were, but in a very famous study, for example, people found that higher temperatures led to people behaving more aggressively. It was kind of a fun study. There's two guys in 1986. They're in Arizona. One guy goes to a place where there's a stoplight. He puts his car there. A car comes up behind them. The light turns green. He sits. And they wait for the entire 12-second light cycle. And the experiment is the other guy's just sitting in the bushes with a stopwatch, recording out of the 12-second light cycle what fraction of time is the guy laying on his horn. Okay? And so the graph of the results is on the right. And what you see, they do this for a whole bunch of Saturdays. And basically, people are more willing to act more aggressively towards a complete stranger, conditional on the exact same stimulus, as a function of the environmental conditions. Okay? So that led to a whole bunch of other studies, one of which is sort of more concerning. They took a bunch of rookie police and basically put them in a training exercise where they're confronted with a video where an assailant is approaching them. And they put some in the hot treatment, some in the cold treatment. And they find that the guys in the hot treatment were more likely to adopt an aggressive posture, draw, and fire their weapon, okay? Even though they're all confronted with the exact same video. So you can see how these types of treatment, and so on sort of an exit interview, it appeared that these cops who were in the hot treatment felt more threatened even though they were facing the exact same stimulus, and that caused them to retaliate in a more aggressive way. So there's something sort of deep in sort of how people are interacting with one another that's affected by the environment, and so we started asking the question, do we see any of these types of large-scale or small-scale patterns of violence around the planet in the modern era when we see the sort of global climate changing. So what we did is we exploited sort of historical flip-flopping of the planetary climate driven by the El Niño Southern Oscillation, which is a sort of overturning of what's happening in the equatorial Pacific. And just to sort of illustrate what's happening during an El Niño, you release a large amount of thermal energy in the equatorial Pacific. And then in the atmosphere, it propagates around the tropics in the form of an equatorial Kelvin wave, leading to heating and drying throughout the entire tropical region. And then after several months, it dissipates. And so what we did is we tried to encode those locations that were getting struck by this large atmospheric wave as it passes through. And so here on the graph, you can see those are sort of the teleconnected locations. And we simply asked the question, what is the probability over the last 50 years that the countries in these red regions start a new civil war conditional on the state of the global climate? And so what you see is that the probability of civil war, when you're in the cooler and wetter La Nina state in the tropics, the probability that a randomly selected country in that tropical band initiates a new civil war is roughly 3%. And then as you shift towards the hotter and drier El Nino state, that probability of civil war starting doubles to around 6%. Now, as a placebo test, what you could do is you could look at the countries that are too far north and too far south to be hit by that wave and ask whether or not their civil wars are in sync with this planetary scale oscillation. And we see that they do have conflicts, like the Balkans, for example, are in that region, but their rate of civil war generation is just not in phase with what's happening in the equatorial Pacific Ocean. Now, that's just one study. It's only like 54 data points because we don't have that many years since 1950. But that result is over on the right, and what we've done since is compared those findings. So the region of the world we're looking at, so the green pixels there, but in other studies we've been able to look at sort of the country scale. We're able to look within these countries at individual pixels, and even within those pixels we've been able to get sort of very detailed data from households at the village level. And at all of these different spatial scales of sort of social organization, we see really common patterns, where as you shift toward these hotter, drier, more extreme conditions, we see higher rates of violence at different sort of social scales, whether or not it's witch killing in these sort of rural Tanzanian villages, or it's sort of more organized forms of political violence all the way up to these civil war triggers. And because of Leif's presentation before, I threw in one more slide. Like, this has been replicated now many times around the world by many different research teams. It's sort of fascinating. I won't go through all of them, but from everything from Hindu-Muslim riots, ethnic violence in Kenya, to the United States. You can look at violent crime, rape. The panel on the bottom right is actually kind of something people find interesting. That's a famous study looking at every Major League Baseball game, actually every at-bat, and you see that pitchers are more likely to hit batters and to retaliate against the other team for hitting their batter, conditional on the temperature during the game. Okay, so we see this pattern over and over at all sort of spatial scales throughout human history, and it's starting to make us think that maybe there's a fundamental relationship between sort of the stability of societies and changes in the climate. So those are two sort of sets of stories where we're thinking about these really extreme conditions. Either you're getting hit by a cyclone, or you're having these large-scale conflicts. But the thing that is actually sort of the most concerning to me, the thing that sort of worries me the most and keeps me up at night, are actually the much smaller things, the sort of 1,000 cuts that I think that could really hurt us. So this is an interesting figure from this crazy researcher in the British military. He basically he wants to know the effect, the ergonomic effect of putting people in a hot room, and he literally sets these guys up from the Navy in there, and they do arm curls until they collapse. Okay, and he's testing whether or not the environment actually affects people's ability to do things, or if putting incentives for them works. And what he finds on the right is a graph where you basically see people's ability to do work is affected by the temperature that they're in, and he changes some condition that he thinks is manipulating their incentives, and it has no effect. So essentially the environment constrains people, and the incentive is sort of irrelevant. This sort of declining productivity of the individual is something that we are now seeing in modern data. So these are two studies from colleagues of mine. On the left, you see sort of corn yields, and we see that corn yields basically decline very sharply on days that have sort of temperatures above 29 degrees Celsius. So you see a real steep decline there. And we see a very similar pattern sort of to corn yields and to the graph before on how labor supply in the United States responds to temperature. And so if you think about sort of the global economy as being this thing that's made up of a large number of sort of fundamental units that are individual people, individual workers, individual pieces of capital, and individual crops, then you might wonder if everything sort of declines in productivity at these higher temperatures, what happens to the larger system? And so you can think about sort of imagining that there's little crops at individual locations and modeling, if they all respond to temperature in this nonlinear fashion, they don't all heat up on the exact same days, but you have a shifting distribution of environments, and it generates a prediction for how the macroeconomy should respond. It should basically be a smoother function with a peak that's shifted to the left of those sort of micro-scale measurements that people have had before. And so we test that with macroeconomic data, and we get exactly what the prediction was. Okay, so we have on the left here results that are looking at all countries around the world, their macroeconomic performance as a function of the temperature they were exposed to in a given year. And on the right, we've actually done it for just the United States. So we follow US counties over the last 50 years, and we can actually estimate foregone earnings, basically counties underperform in years where they have more hotter days. We're actually estimating daily income. So in a US county, for example, on a hot day, there's roughly $20 less in earnings per man, woman, and child in that county, okay, just for a sense of scale. So we see the same pattern both around the world and in sort of the world's most sophisticated modern economy. And sort of a lot of people have thought, well, given our level of technology, given our ability to innovate, this shouldn't be as much of a problem around the world. It turns out if you break up the global data into the rich countries and the poor countries, you get statistically indistinguishable results, although the rich countries are a little flatter. Maybe that's an indicator that they're not as strongly affected. But when we go to the United States and we just look decade over decade, we see that over the last 40 years, even if we just look at data that's coming from the 21st century, we recover essentially the same result. Okay? And so there's almost no evidence that we're adapting in an effective way here. So this is the thing that keeps me up at night, because if we don't adapt and if we follow those same sort of patterns into the future, then we have sort of a really serious situation in which economic growth is going to slow down relative to what it would look like if we stayed at sort of pre-industrial temperatures or even current temperatures. And so the map on the top is sort of showing you a measure of how much individual GDP per capita in individual countries would change in a simple simulation where we roll things forward following those results. And then for places that are sort of starting out cool, you actually are going up the hill with warming, so you actually benefit from warming some. Whereas places that are already hot, they're going down the hill and they're harmed by warming. So when we look around the world, you see that the places that are cool are actually benefiting a bit, and Europe on net actually comes out a winner. In North America, we're kind of sitting on the top of that hill, so the benefits sort of offset the gains more or less, and it's kind of a wash given the level of uncertainty. But through the tropics, in places like South Asia or Africa or South America, you see that things really sort of hit the fan. If you look at this, you sort of add it up and look at what world income would be projected to be. On the left, you see sort of a projection in which you see global GDP in the median case is declining around 23% per capita. But importantly, there's a lot of spread there, right? There's a lot of statistical uncertainty. And so one thing climate change does for us is it makes the world more uncertain because, in part, we can't determine exactly what's going to happen to us if we change things. And on the right, you see a summary of sort of the distributional consequences. Because the places in the world that tend to be hot and are on the right side of those graphs tend to also be poorer today, when we move into this future, we see that the sort of the brunt of the costs are being borne by the sort of 60% of the global population that is poorest today. Okay? And so for the wealthiest part of the world, there are still losses, but we would dramatically widening global inequality. So, I mean, these are, I just want to wrap up. These can sound like kind of scary ideas, I think, sometimes. When I sort of talk to people, they come out sort of feeling depressed about it. But I'm actually in the policy school, and I tell people that, that's exactly the wrong interpretation. This is the first time in human history that we've had these kinds of computational tools where we've been able to use data, to use science, to see sort of ahead. In the past, decision makers relied much more heavily on like rolling dice, looking at the stars, asking like fortune tellers what might happen in the future to make decisions. Finally, we can do this in a rational way. We can have an open discussion about sort of which world we want to live in. The work that we're doing is sort of trying to paint a picture that's much more vivid for decision makers and for the public. This graph right here, the temperatures are the different colors on the left. This is sort of business as usual. On the right is sort of a strong mitigation scenario. And the night lights are rescaled to reflect the economic growth in that simulation. And so I think that by doing this work, helping us understand what lies ahead, we can make decisions and sort of avoid outcomes that we really would find distasteful for us, our children, and our grandchildren. Thanks a lot.